Hi, I'm Andrea and welcome to Productive C#. In this video, I'm going to show you how the coordinate system works in GoDot and how you can load and manipulate scene and nodes. I'm going to do that by showing you how to create a simple screensaver where there are a lot of stars of different sizes, of different colors, all bouncing around the screen at different speeds. This is going to be fun. So let's start. The first things I want to do is to go in project settings and change the size of the screen. It's very common to set it to full HD for desktop games, and that's what I'm going to do, to 1920 to 1080, and I'm going to set full screen. I'm also going to change the rendering environment default clear color to black, so that it's sort of more close to a desktop, to a space background. The next step, I want to create a new scene that represents my star. If I do scene, new scene, 2D scene, I can give it a name star, okay? And then what I want to do is to actually add a sprite to the scene. I already have an image called star.png that I can grab it and put it on the screen. I want to position this to coordinate 0, 0, so that the center of the sprite is actually the coordinate where you're going to position the scene in the game. So let me call that star and save it. This object here is a sprite 2D. It's basically an image that you're going to add in the game. Perfect. Now that I have a scene, I want to be able to load it dynamically in the game. All right? And I can go back to Visual Studio and do that. So add child is the method that we need to use to add a node into a scene. But first, I need to actually load the scene and then instantiate it. I need to do GoDot.load packet scene. I'm going to specify the name of the scene, that is star.tscn, and then the instantiate method. So this one is loading, the actual scene, and this one is instantiating it. Okay? If I now run this, we should be able to see a star on the top left hand corner here being loaded. I want to make every star independent, so to independently position themselves and also move. So in order to do that, I need to go back to the scene, to my star scene, and attach a script to it. That is a star.cs. And the first things I want to do is to position the star randomly on the screen. In order to do so, though, I need to be able to get what is the width and the height of my screen. And I can do that in GoDot using the getViewportRect method. So I want to create a property that I'm going to call screen size. And I'm going to assign the result of calling the viewportrect.size method. This is returning a vector2. Oh, so not a property, I want a field. This screen size now represents the width and the height of the screen. I want to set the position property to a new vector that is going to be the screen size x times a random number between 0 and 1. So I can actually choose any numbers between 0 and screen size x. And I can use a GoDot function called roundf to help me with that. And I can do the same for the y coordinate. gd.roundf. If I now run the code, you would be able to see a star positioned randomly. It didn't quite work because I probably haven't saved star properly. If I click play, it's now being positioned randomly. Every time I run it, it will position it differently. So let's try to actually spawn a lot of different stars. Okay, let me go to game and let me do this in a loop. Let me do 100 stars and see what happens. Boom! Oh my God! Now we have a lot of stars. Obviously, I want to change the size of them, and let's do that in star. And I can do the same kind of trick, but in this case, I'm going to set the scale property. That is also a vector too that represents how much you want to scale the image. And I'm going to do that by multiplying the vector 2, the vector 1, 1 times a random number between 0 and 1. So this is going to make the star, a random size between 0 and the actual current size of the star. Let's run it and see what happens. There we go. Now I got like a lot of stars, but of different sizes. The next things I want to do is to change the color of these images, and I can do that by actually setting using the modulate method on the actual sprite of the star. But as you know, star is actually the scene. How can I get a reference to the actual node on a scene? Well, you can do that using a method that is called getNode, and you can say I want to get a sprite 2D whose name is image, and then I want to set the modulate property to a color of my choice. Let's make red for now. So what I'm doing, if you look at the actual editor, the star scene contains a star sprite 2D. Actually, I call it star, so this one should be star. So this needs to match the name. And I'm going to actually getting a reference to it, and so I can actually manipulate it. So if I now run it, all the stars should now be red. Perfect. So you can imagine how I can create a random number. I can just create a color and use GCRandF again for each element of my color, for all the components of my color. If I run this now, I'm going to get a lot of different colors now. Perfect. So what's the next step? I think start to make some move. Let's make them move. As you know, this process method is called multiple times, and delta is the elapsed time since the previous frame. Okay? So what we need to do is to obviously change the position of the star in a particular direction. We want the direction to be also random. So let me create a private field that represents the direction of movement. And I want to initialize it here, similar to what I did for the other properties. And what I want to do is to create a vector that could be from -1 to 1 in any direction. And I can make it of magnitude maximum, 300. That is the maximum speed I want to be able to provide. So let's say 300 times. I'm going to create a new vector 2. And now I need to use another function that allows me to do a random range between -1.0 and 1.0. Oh, I need to use double, unfortunately. And then I need to cast it to be able to do that. And I do the same for the other coordinate. So I'm going to get a number between -1 and 1 times 300. So I'm going to get a vector, a random direction vector of maximum 300 pixels in any direction. And what I need to do is I'm going to simply add that to my position times the delta. Oops. Times the delta, because I want to make sure that the direction is 300 pixels per maximum per second. Okay? So let's see what happens. There we go. This is starting to be nice. You got a lot of stars all moving around in different directions, but at the moment they're not bouncing around the screens because we didn't have the logic to handle that. And that's the final piece of the equation that is going to be checking the bound of the screen. This is not too difficult. I can check the position x. If it's greater than the screen size x, or the position of x is less than 0, then what I need to do? I need to change the sign of the direction, the x coordinate in the direction. So I'm going to create a new vector where the direction x is now -a and y is preserved. So if we go outside the bound of the screen on the left or on the right, we invert the x coordinate of the direction. And we can do the same for the y coordinate as well. In this case, instead of inverting the x of direction, I'm going to invert the y. And now all the balls should start to bounce. But to make it even more fun, let's add 200 and see if it's even more interesting. Boom! this is all bouncing now. These are a bit too big in my opinion, so probably we can make them a little bit smaller, the scale. So I probably would add some sort of 0.3 here, just to make it a little bit smaller. But obviously you can adjust the things as you want to make it as visually appealing as you want. There we go. Now we have a sort of screensaver with a lot of stars bouncing around the screen of different colors, of different sizes, of different speed, and it's quite a pleasant experience. So we've learned a lot in this video. Let me quickly recap. So you can use the GoDot editor to create new scenes. Each scene can contain as many nodes as you want. In this case, it's containing just a simple sprite. You can easily load dynamically new scene using the gd.load method, and also you can instantiate an independent instance of a scene using the instantiate method. You can obviously add the node in the scene using the addChild method. And then a lot of the logic of a particular scene can be encapsulated in a specific script associated to each scene. And you can change the position of the node, the scale, you can set the direction, and you can also update this position over time in the process method to actually make it move. And you can actually do any math you want to make sure the objects move as you want and they are positioned in different places as you want. There's a bunch of random function generations, random function that GoDot provided. It can be handy to actually add some randomness in your game. And finally, there is a way to actually get an handle to a particular node in a scene by using the getNode method. And that in this case we used in order to actually get an instance, a reference to the instance of the texture we want to actually modulate, and then we assign it to a different random color. And that's pretty much what I wanted to show you. Now you know how to manipulate scenes, nodes, compose scenes and nodes to generate the design of your game, and then move objects around, scale them, position them, and dynamically instantiate as many instances of scenes that you want. And this information is going to be very, very handy for you to build any sort of games using GoDot and C#. And thank you very much for watching.